Hello friends, welcome back to the series classes that is certified in the Risk and Information System Control, Part 2, Domain 4. Ladies and gentlemen, we are going to discuss understanding software and operating system in this part. Friends, this is where the magic behind every digital device begins. Whether it is your smartphone, laptop or tablet, the seamless experience you enjoy is powered by complex systems working in harmony. But how exactly does this happen? What role does software play? And how does the operating system act as the foundation? Friends, we'll deep dive into the world of software and operating system, breaking down how they work together to run everything from basic apps to intricate programs. So stay with us as we explore the hidden layers of technology that make our digital lives possible. So welcome you all to the today's session. Friends, let's talk about something that impacts almost everyone in the daily's work, productivity tools like Microsoft Word or Excel. Here is a surprising statistics for you. Did you know that the staggering 80% of the users utilize only 20% of a software feature? That's right. Whether it's Word or Excel, most people stick to the basics. Typing, formatting, or making simple tables while missing out on the real part behind these tools. Features like mail merges, macros, or automation techniques like PivotTables or Power Query in Excel remain under the radar. Imagine the productivity boost that could be unlocked if users just tapped into these capabilities. And it is not just about using the tool, it is also about using them efficiently. Research tells us that only 40% of the users regularly use the keyboard shortcuts, even though these could be simple combination cut down the task time by as much as 30%. We all know that the Ctrl+C and Ctrl+V, that is copy and paste, but how many of us know about advanced shortcut like Ctrl+Shift+L to apply filters in the Excel? This knowledge gap can be easily bridged through proper training. So the bottom line is that there is untapped potential in how we use technology every day. And unlocking that potential could revolutionize productivity in ways we might not even realize yet. Moving next, let me bring your attention to a significant gap in how businesses are utilizing automation tools. Friends, according to a survey conducted by a Spicework, a staggering less than 10% of the business's users are fully aware of the automation tools, like macros in Excel. These are the tools designed to automate repetitive tasks, yet they remain widely underutilized. The consequences? Time is being wasted on manual processes that could easily be automated. In fact, companies could save between 15 to 25% of their time spent on the routine tasks if these tools were fully embraced. Now let's talk about the training, or rather lack of it. A study by Better Cloud shows that 52% of the companies offer no software training to the employees. This means key features and functionalities remain unexplored, leading to inefficiencies in everyday workflow. On the flip side, companies that do invest in the proper software training report a productivity boost of up to 40%. And that's the difference training can make. What this data tells us is clear that there is an urgent need to prioritize software literacy program, and these programs can empower employees to fully harness the potential of the tools they already have at their fingertips, leading to dramatic gains in productivity and overall job satisfaction. The knowledge is out there, waiting to be unlocked. It's just a matter of investing in the right training and resources. Moving to the topic, first we'll discuss about understanding software and operating system. Friends, ever wondered what makes your computer or smartphone run smoothly? It's all thanks to the software and operating system. Friends, then the first question arises, what is a software? Let us start by understanding a fundamental concept, software. Simply put, software is the engine behind everything you do on a computer or device. Whether you are browsing the web, editing documents, or playing games, it is the software that makes all of this possible. Now there are different types of software. First, we have system software, which include the operating system that runs your device. More than that in a moment. And then there is application software, program like Microsoft Word, Adobe Photoshop, or even the apps you use daily like Instagram or WhatsApp. Lastly, there is a utility software. These are the tools that help you manage and maintain your system, things like antivirus program. To give you a simple example, when you are using a web browser to watch YouTube videos, you are interacting with application software. It's what power your experiences behind the scene. So as you can see, software is not just a technical term. It's the driving force behind every digital task you perform. Next, what is an operating system then? Friends, let's talk about the operating system, something you interact with every day but might not think much about. The operating system or OS is the core software that runs the show. Think of it as a middleman. It's what bridges the gap between you and the machine. And without it, your hardware and software would not be able to communicate effectively. Now there are several popular operating systems out there. You have got the Windows, which is the go-to for most personal computers and laptops. Then there is a Mac OS designed specifically for Apple Mac computers, and for developers and technical enthusiasts, Linux is a popular choice because it is open source. And of course, on your mobile device, you have Android and iOS, the powerhouse behind most smartphones. But what does an operating system actually do? A lot more than you might think. First, it gives you the user interface. The desktop on your computer or a home screen on your smartphone. It is what you interact with. Then it's all about resource management, making sure your CPU, memory, and storage are working efficiently. It also manages tasks, ensuring that multiple programs can run smoothly at the same time. And finally, there is a file management, organizing and controlling how data is stored and retrieved on your system. In essence, friends, the operating system is the unsung hero of your digital world, quietly working in the background, ensuring everything runs like clockwork. And last, we'll discuss about what the difference between software and operating system. Let's break down the key differences that often confuses people. The difference between the operating system and application software. Think of the operating software as the foundation of a building. It is the system software that manages your hardware, making sure everything runs smoothly. Friends, application software, on the other hand, is like the house built on the top of the foundation. It is there to perform specific tasks like editing a document or browsing the web. Here is a simple example. When you open a web browser, the software is what you interact with. But it is the operating system that handles all the behind the scene work, communicating with your computer hardware to make sure your experience is seamless. Without the operating software, none of this would be possible. Moving next, let's talk about the backbone of all the modern technology software. Essentially, friends, software is the programming that allows hardware like computers or smartphones to perform specific tasks. It is made up of instructions that tell the hardware what to do and how to do it. The beauty of software is its flexibility. Unlike hardware, which you need to physically change, software can be updated or modified, allowing your device to adapt and improve over time. Now there are different types of software, each of with its own rule. At the core, we have operating system, think Windows, Mac OS or Android. These systems manage your device's hardware and other software, creating the environment where you can interact with your device. Then we have utilities, which are smaller programs like antivirus software or desk cleaner. These tools maintain and optimize your system performance. And drivers are another crucial part of the ecosystem that act as a translator between your hardware and the operating system. For example, a printer or a graphic card needs a driver to communicate effectively with your computer. Similarly, firmware is a software embedded in devices like routers or even washing machine, ensuring that they function properly. While firmware does not change often, it is vital for the device's performance. Then we have middleware, the bridge between different software programs. This enables applications to work together seamlessly, allowing data to be shared efficiently. APIs or application programming interface work similarly by letting different software systems interact. For instance, when an app accesses Google Maps to show your location, that's an API at work. And of course, we can't forget the application. These are the software programs you use every day, from Microsoft Word to Photoshop or Instagram. Applications are designed for the specific tasks, and they are the program we interact with the most. We also have database management systems like SQL or Oracle, which handle large volume of data, making sure information is stored and retrieved efficiently. Finally, networking tools are essential for communication between devices, whether on a local network or the internet. VPNs or firewalls and other tools ensure that data flows smoothly and securely. In short, software is what brings your device to life. It is what enables hardware to perform tasks, manage data, and interact with you. The best part, it can be updated without ever touching the hardware, making it one of the most dynamic and powerful elements of our technology-driven world. Moving next we'll talk about the area of concern in the software. Friends, when we talk about software, there are several critical areas that need constant attention to ensure that system runs smoothly and securely. First, there is the issue of security vulnerabilities. That is, weak points in the system that could be exploited by hackers. Then we have software bugs, those annoying glitches that disrupt your experiences. Addressing these problems quickly is the key. Performance optimization is another important factor. Software needs to run efficiently, making the best use of resources like memory and processing power. Then there is user privacy. Ensuring that personal data is protected is non-negotiable in today's world. Compatibility is also essential. The software must work across different devices and platforms, whether it is a desktop, smartphone, or tablet. Finally, regular updates are crucial to stay ahead of technological advancement and security threats. These updates ensure that the software remains reliable, secure, and up to date. Friends, managing all these concerns is vital for ensuring that software operates smoothly, protect users, and deliver a seamless experience across applications and devices. In this, the first point we'll discuss about the bugs. Ladies and gentlemen, bugs in software are essentially mistakes or flaws in the code that cause it to behave unexpectedly or incorrectly. These can come in many forms, but two common types are logic flaws and semantic errors. Friends, logic flaws occurs when software instructions are incorrectly designed, leading to undesirable outcome even though the code technically runs. On the other hand, semantic errors happens when the code meaning or behavior is misunderstood by the programmer, causing the program to perform tasks in a way that was not intended. Both types of bugs can lead to malfunction, crashes, or unexpected behavior, which is why debugging and testing are crucial part of the software development process. Next, about the patching. Patching refers to the process of updating software or fix bugs, improve performance, or address security vulnerabilities. When patches are not applied regularly, it can leave the software exposed to known vulnerabilities, making it easier for cyber attacks or system failure to occur. Lack of patching can also result in performance issues, as outdated software may not work efficiently with newer hardware or other applications. Regular patching is essential to keep software secure, stable, and optimized, ensuring that any known issues are resolved before they can cause significant problems. Next, about the access control. Friends, access control refers to the system and protocol that determine who can access specific data, application, or areas within a software system. When access control is inadequate or not properly governed, it can lead to unauthorized user gaining access to sensitive information or critical system functions. This can result in data breaches, security vulnerabilities, and misuse of resources. Poorly implemented access control can also make it difficult to track who is using the system and what action they are performing, which can compromise accountability and lead to serious security risks. Ensuring that access control measures are properly designed and strictly enforced is crucial for maintaining the integrity and security of software system. Next, about the sensitive information. Friends, the disclosure of sensitive information occurs when confidential or private data such as personal details, financial records, or proprietary business information is unintentionally exposed or accessed by the unauthorized individuals. This can happen due to software vulnerabilities, inadequate encryption, poor access control, or human error. Friends, when sensitive information is disclosed, it can lead to identity theft, financial loss, legal consequences, or reputational damage for individuals and organizations. So protecting sensitive data is critical, and measures such as encryption, strict access control, and secure data handling practices are essential to prevent unauthorized disclosure and maintain privacy. Moving next, ladies and gentlemen, in addition to the major areas like bugs, patching, and access control, there are several other concerns that can affect the performance, security, and reliability of a software. These includes modification, version control, validation, and service and ports. Let us understand it one by one. Addressing these concerns is vital for ensuring that software not only functions as intended but also remains secure, efficient, and user-friendly over time. First, let us talk about something that can have serious consequences in the digital world: improper modification of information. This happens when a data within a software system is changed in an unauthorized or incorrect way. Whether it is intentional or not, the result can be disastrous: data corruption, loss of accuracy, and breaches of integrity. Whether it is due to malicious attack, human error, or even a flaw in programming, improper modification can disrupt entire operations, compromise decision making, and expose sensitive information to significant risks. So how do we prevent this? Friends, strong validation checks are a must, alongside auditing processes that ensure every change is recorded and verified. Access control mechanisms are also essential, restricting data modification to only authorized users. In short, every step must be taken to ensure that critical data is protected and any changes are properly tracked and controlled. Because in today's world, even a small mistake or unauthorized change can have a far-reaching consequences. Next, we'll talk about version control. Version control, a crucial yet often overlooked aspect of software development. Simply put, it is a process of tracking and managing changes to software code over time. Without proper version control, things can quickly spiral into chaos. You risk overwriting important updates, losing historical data, or even introducing new bugs because edits were not properly tracked. Now imagine multiple developers working on the same project without version control. It becomes a nightmare. And with team members unintentionally overwriting each other's work, and here is the worst part, if a new change causes issues, rolling back to a staple version becomes almost impossible without a proper system in place. This is where version control system like Git comes in. They allow teams to keep a detailed record of every change made to the code, making collaboration seamless. And if something goes wrong, you can always revert to an earlier staple version. It's not just about efficiency, it is about ensuring that projects remain organized, trackable, and secure. Next, we'll talk about validation. Friends, when software processes input or output without proper validation, it exposes the system to a host of problems and vulnerabilities. Input validation is key. It ensures that any data entered into the system, whether by user or the system, is correct, secure, and in the expected format. Without this crucial step, the software could end up processing incorrect or even malicious data, leading to crashes, data corruption, or more serious security risks such as SQL injection or buffer overflow attacks. But it does not stop there. Output validation is just as important. This ensures that any data leaving the system is properly formatted and accurate. Without this, sensitive information could be exposed or faulty data could be sent to other systems, causing further damage. The takeaway is simple. Strong validation practices are not optional. They are essential for maintaining the security, integrity, and reliability of any software. Neglecting these practices opens the door to the errors, vulnerabilities, and potentially devastating consequences. Next, we'll talk about services and ports. Friends, running unnecessary services or protocols on a system is a major security risk. Each service or protocols communicate through a specific network port, and if these services are not essential, they expand the system's attack surface, giving cyber criminals more opportunity to strike. Then there are open ports. Even though they are not in active use, they can be exploited by attackers to gain access to your system or launch malware. Friends, if these ports are not properly monitored or secured, they essentially becomes open door for hackers. So what is the solution? Regularly review and disable any services or protocols that are not necessary for your system's operation, and close any unused ports to minimize the risk of attack. Not only will this reduce security threat, but it will also improve the overall performance of your system. In short, managing open ports and minimizing unnecessary services is a vital step in securing your system and preventing vulnerabilities from being exploited. Moving next. Friends, did you know that many of the cyber security breaches we hear about could have been avoided with better approaches to the software development? Let's talk about the Security Development Lifecycle, or SLDC, a process that integrates security practices into every phase of software development, from design to deployment. Friends, now the absence of formal security-focused security development lifecycle is a major issue. Why? Because it increases the risk of vulnerabilities creeping into the software at various stages of development. If security is not embedded in the process, the software is more likely to have weaknesses that attackers can exploit after release. A security-aware software development lifecycle ensures safeguards like threat modeling, secure coding, regular security testing, and code reviews are in place. These steps help identify and fix vulnerabilities early, before the software even reaches the user. Without these measures, critical issues might go unnoticed until it's too late, leading to data breaches, compromised systems, or expensive emergency fixes. Incorporating security into the entire development lifecycle is not just an option, it is essential. It ensures that software is not just functional but also resilient against modern threat, reducing the risk of post-launch security incidents. In today's world, this kind of proactive approach to the security is non-negotiable. Moving next, ever wondered what keeps your computer or smartphone running smoothly, allowing you to browse the web, open apps, and play games? Friends, let's talk about the operating system or OS, the essential software that bridges the gap between you, the user, and the hardware of your device. Whether it's your computer or smartphone, the operating system allows you to interact with the machine without needing to know the technical ins and outs of how it works. It manages everything from your processor and the memory to storage and external devices like printer or USB device. In short, it ensures that every part of your system functions smoothly together. There are different operating systems for different devices. For computers, you have got Windows, Mac OS, and Linux, while smartphone and tablets most run on iOS or Android. Each of these operating systems has its own unique interface, features, and capabilities, but they all share the same goal: providing you with a user-friendly platform to manage hardware and run your applications. In essence, the operating system is what makes your device usable and efficient, allowing you to focus on the task at hand without worrying about how the hardware works. Moving next, when discussing operating system, several issues can arise that impact the functionality, security, and overall performance. These include potential security vulnerabilities, code quality, complexity, and inadequate user access controls. So addressing these concerns is crucial for ensuring that the operating software runs smoothly, remains secure, and provides a stable platform for user and applications. So let's discuss it one by one. Let's talk about the unpatched vulnerabilities, a critical issue in the world of cybersecurity. These are the security flaws in an operating system or software that have been identified but not yet fixed. And here is the danger. Attackers can exploit these weaknesses to gain unauthorized access, steal sensitive data, or even cause system failures. When these vulnerabilities are left unpatched, the system is wide open to threats like malware, ransomware, or hacking attempts. And this is why regular updates and patches are absolutely essential. They fill these security gaps, protecting your system from known risks. Failing to apply these patches does not just put individual user at risk, it can expose entire organization to cyber attacks. In today's digital world, Staying updated is not just a recommendation, it is a necessity for safeguarding your data and your system. Moving next we'll talk about the code quality. Friends, poorly written code can cause serious problems in software, and it is more than just inefficiency. It leads to instability and, more importantly, security vulnerabilities, a common issue. Buffer overflows when a program writes more data to a memory buffer than it can hold, potentially allowing attackers to execute malicious code. But that's not all. Improper memory management, failure to handle errors, and insufficient input validation are other major concerns. Poor code quality does not just result in bugs that affect functionality, it opens up security risks that can be exploited by hackers. So, how do you prevent this? Ensuring high code quality through rigorous testing, code reviews, and following best practices in development is essential. It is the foundation of creating reliable and secure software that stands up to modern threats. Moving next, we'll talk about the complexity. Friends, as the software system and operating environments grow more complex, managing them becomes a daunting task. With this complexity comes a higher risk of misconfigurations, setting or options they are incorrectly set, leaving the systems exposed to the security risks, performance issues, or functional problems. The more complex a system is, the harder it is to understand, maintain, and troubleshoot. This often leads to human errors during configuration or updates. And when these misconfigurations occur in critical areas like firewall, databases, or network setting, the consequences can be severe, ranging from cyber attacks and data breaches to the operational failure. So what is the solution? Simplifying system architecture and using automated configuration management tools. These measures can be significantly reduce errors and minimize the risk associated with the complexity, ensuring systems are secure and efficient. Moving next about the access control. Friends, weak access controls refer to the insufficient security measures that governs who can access a system, application, or data. When access controls are not properly implemented or enforced, unauthorized users may gain access to sensitive information or critical system function. This can lead to data breaches, loss of data integrity, or unauthorized changes to the system. Weak access control can also result in internal threats, where employees or insiders with excessive privilege accidentally or maliciously misuse their access. So to mitigate these risks, it is essential to implement strong access control measures such as role-based access control or multi-factor authentication and regular auditing of these permissions to ensure that only authorized individuals have access to the critical resources. Moving next we'll talk about some more concerns in the operating software. Friends, in addition to the major issues like security vulnerabilities, weak access control, and performance bottlenecks, operating systems face other challenges that can affect their efficiency, security, and user experience. These concerns include interoperability, uncontrolled changes, service and ports, and updates. So addressing these additional concerns is crucial for ensuring that the operating software operates smoothly, securely, and effectively across various environments and use cases. In this, first we'll talk about interoperability. Friends, lack of interoperability occurs when a system or software cannot effectively communicate or work with other system, software, or devices. This can create significant challenges in environments where diverse technologies need to integrate and share data. Incompatibility between systems may result in reduced functionality, data silos, and inefficiencies in workflow. So for businesses, this can hinder collaboration, limit scalability, and increase cost associated with finding workarounds or adopting additional tools to bridge gaps. Ensuring interoperability is crucial for seamless communication, smooth data exchange, and optimized performance across different platforms and services. Next, we'll talk about the uncontrolled changes. Uncontrolled changes refer to a modification made to an operating system or software without proper oversight, documentation, or approval. This can lead to systems instability, security vulnerabilities, or compatibility issues, as changes might unintentionally disrupt existing functionalities or introduce new bugs. Friends, uncontrolled changes often occurs when updates, configurations, or patches are implemented without thorough testing or adherence to a change management process. And to avoid these risks, organizations should adopt formal change control procedures, ensuring that all changes are tracked, reviewed, tested, and approved before being applied to production environments. This helps to maintain system reliability, security, and consistency. Moving next we'll talk about the service and ports. Friends, unnecessary services and open ports on a system can create serious security and performance risks. Services and protocols that are not essential for the system's operation may still be running in the background, consuming resources and potentially exposing the system to vulnerabilities. Each open port can act as a potential entry point for cyber attacks, as hackers can exploit these to gain unauthorized access or launch malware attacks. So managing these risks involve regularly reviewing and disabling unnecessary services and closing open ports that are not in use. This reduces the system's attack surface, improves security, and optimizes performance by freeing up systems resources. Friends, proper configuration and monitoring of services and ports are critical to maintaining a secure and efficient operating environment. Moving next. Friends, are you letting your device updates automatically? While it sounds convenient, there are some hidden risks you should know about. Let's talk about updates. Friends, while automatic updates are important for keeping software secure and up to date, they can pose certain risks on personal device. One potential issue is system instability, where an update might introduce bugs and cause incompatibility with existing applications, leading to crashes or malfunction. There is also a risk of data loss, as updates can sometimes overwrite or disrupt important files. Additionally, automatic updates may occur at inconvenient times, interrupting work or requiring a system restart when it is least expected. And another concern is incompatibility, especially if the update is not fully compatible with older hardware or software, which can result in reduced performance or limited functionality. Finally, while updates are intended to fix security vulnerabilities, they can occasionally introduce new security gaps if the update itself has flaws. So to minimize these risks, users should back up their data regularly, manage update settings carefully, and ensure compatibility before installing updates. So worried about operating software vulnerabilities? Friends, in today's digital age, securing your operating system is more important than ever. Friends, mitigating operating system risks require strict control over changes, patches, and configuration to maintain security and stability. A key approach is system hardening, disabling unnecessary services and protocols, and changing default account and password. This reduces the system's attack surface, making it harder for the attackers to exploit vulnerabilities. Then there is a critical aspect of patch management. It is not just about applying patches, it is about identifying vulnerabilities, thoroughly testing patches for compatibility and stability, and ensuring they are implemented in a timely manner to avoid disruption. By following these steps, we can minimize risk associated with misconfiguration, vulnerabilities, and unauthorized access, ultimately strengthening the overall security of the operating system. Let's talk about something absolutely critical for system security, that is administrative control and user roles. Now, this is a step that often gets overlooked, but it is vital. Setting up proper control means you limit access to the most sensitive areas of your operating system. Not everyone needs access to everything. So by defining specific user roles, you ensure that only authorized individuals can reach critical part of your system. And this significantly reduces the risk of a security breach. And here is another key step that often gets ignored, that is changing default credentials. As soon as you install a new operating system or software, the first thing you do is change the default username and password. Why? Because leaving them unchanged is like leaving your front door wide open. Hackers know that these default credentials, and if you don't change them, you are essentially handing them a free pass into your system. In short, limit access, change default credentials, and you have already taken two major steps towards securing your operating system. Moving next, friends, when you use apps every day, from sending email to editing photos or even playing games, but have you ever wondered how these applications actually work? Friends, application software interact with the operating system using APIs, that is application programming interface, or other programming methods. Applications serve as a primary tool through which users interact with a device, allowing them to access information, perform transactions, and utilize system features. Whether it is a word processor, web browser, or mobile app, these programs rely on the operating system to manage resources and execute commands, providing a user-friendly way to perform specific tasks and manage data. Applications are an essential part of the user experience, bridging the gap between the system's capabilities and the user's need. Moving next, let's discuss about the concern in the application software. Friends, applications are the powerful tools that we use every day. But did you know that behind the scene, they faces a number of challenges that can affect their performance and security? Application software can face various challenges that impact functionality, security, and user experience. These concerns may include data validation, sensitive data, modification, logic, and bugs. Additionally, poorly designed user interfaces and lack of support for scalability can reduce the effectiveness of applications, making it crucial to address these concerns during development and maintenance. First, let's check it out one by one. First is about data validation. Friends, one of the most critical issues in the application software is ensuring that input data is properly validated. Without proper validation, incorrect or malicious data can be entered, potentially leading to security breaches or crashes. Just take an example, like an app might allow user to input numbers where only text should be allowed, causing unexpected errors. Friends, a study by OWASP, that is Open Web Application Security Project, reveals that inadequate input validation is among the top 10 security vulnerabilities in the web application. Poor input validation can lead to vulnerabilities such as SQL injection and cross-site scripting or application crashes. According to the Open Web Application Security Project, 50% of the security breaches are caused by an inadequate data validation. In 2018, a significant vulnerability was discovered in a Facebook View as features, which allowed attackers to input malicious data, leading to the exposure of personal information from more than 50 million user accounts. As a measure, rigorous input validation protocol and security testing such as fuzz testing can be identified and mitigate these risks. Moving next, let's talk about the sensitive data. Friends, application often handles sensitive information from personal details to the financial records. Failure to secure sensitive data can lead to unauthorized access, data leaks, or compliance issues with privacy laws like GDPR or HIPAA. An online shopping app that does not encrypt user payment information risks exposing credit card details to hackers. According to the Verizon Data Breach Investigation Report, 45% of the data breaches involve sensitive personal data, with poor data management and encryption practices being leading causes. Mishandling sensitive data can lead to a costly breaches, with average cost of data breach reported around $4.45 million by IBM 2023 Cost of the Data Breach Report. In 2017, Equifax suffered a massive breach due to unpatched software, leading to an exposure of 147 million people's sensitive data, including social security numbers and financial details. To mitigate this, implementing end-to-end encryption, secure database configuration, and compliance with GDPR or HIPAA or PCI DSS can greatly mitigate the risks associated with sensitive data mishandling. Moving next, let's talk about the data modification. Data integrity is crucial in applications, and risk of unauthorized or accidental data modification can compromise the accuracy and reliability of an application. Weak access control or inadequate tracking of data changes can lead to unauthorized data alterations. A banking app that does not properly secure its database could allow unauthorized users to change transaction records. A report by Forrester Consulting highlights that 40% of the companies experienced unauthorized data modification incident in the past year, leading to significant operational inefficiencies and financial losses. Without strict access control and auditing, accidental or malicious changes to critical businesses' data can compromise application integrity and reliability. In 2020, a security flaw on Twitter's internal tool allows attackers to gain control of high-profile accounts and modify account details. This breach led to unauthorized tweets from accounts like Elon Musk or Barack Obama, causing a public relation crisis and financial loss. So to mitigate, enforcing role-based access control and maintaining immutable audit logs can help track data modifications and prevent unauthorized access. Next, about the logic and bugs. Friends, applications must follow specific logic to perform their functions. When logic is flawed or bugs are introduced, the app may not behave as expected. Logic errors can cause crashes, incorrect calculations, or unexpected behavior, leading to a poor user experience or even security vulnerabilities. A shopping cart app might miscalculate total cost due to a logical error, leading to a user frustrations and potential financial loss. A JetBrains developers ecosystem survey found that 65% of developers cite logic errors as most common source of application bugs, with 27% of developers indicating these errors lead to major application failures. In 2018, Amazon's Prime Day experienced issues where a logic error applied unexpected discounts, leading to products being sold far below their value, costing the companies millions in potential revenue. So to mitigate, comprehensive unit testing, integration testing, and test-driven development approach can reduce the likelihood of such errors affecting production environment. Moving next, let's talk about some more concerns in the application. Friends, applications face accidental concern that can affect their performance and security. These include issues like lack of logs, version control, source code, and access control. Additionally, user experiences, design flaws, frequent crashes, and insufficient documentation or support can further undermine the effectiveness of an application. Managing these concerns is essential for ensuring applications run smoothly, remain secure, and meet user expectations. In this, the first we'll talk about logs. Friends, logs are essential for tracking user activity, identifying bugs, and detecting security breaches. So without proper logging, it becomes difficult to troubleshoot issues or analyze system behavior during or after an incident. If a banking app does not log failed login attempts, a hacker would keep trying different passwords without being detected. So overall, friends, logs are essential for tracking system activities, errors, and security events. A lack of logging makes it difficult to monitor system behavior, troubleshoot issues, and detect security breaches. And without proper logs, administrators are unable to track what actions were performed, who performed them, or when they occurred, leading to a loss of accountability. And this can leave the system vulnerable to undetected attacks or errors that go unresolved. And implementing detailed logging practices help to ensure that all significant activities are recorded, aiding in diagnostics, security audits, and incident response. Next, we'll talk about the version control. Version control is vital in software development for tracking changes in the source code and ensuring consistency across development environment. A lack of version control can lead to conflicting changes, bugs reappearing, and difficulty in managing updates and patches. A developer accidentally reintroduces an old bug because the correct version of the code was not used for updates. A lack of version control means there is no structured system in place to track changes to software code, documents, or configurations over time. This absence can lead to confusion, and developers may overwrite each other's work, making it difficult to identify or undo changes. So without version control, it becomes challenging to track the history of modifications, collaborate effectively in teams, or revert to a stable version of the software after a faulty update. This can result in increased errors, lost data, and reduced productivity. So implementing a version control system such as Git help organize changes, foster collaboration, and provide a clear record of revisions and updates. Next, we'll talk about the source code. Friends, source code is the backbone of any application, and exposing it to unauthorized user is a major risk. If a source code is not protected, hackers can easily exploit vulnerabilities in the app. But just understand it by taking an example. Friends, a code leak in an e-commerce platform source code could reveal security flaws that allow attackers to access customer data. So losing source code is a critical issue that can have severe consequences for a software project. A source code is the foundation of any software application, containing the instructions that enable the software to function. If the source code is lost or become inaccessible, it can halt development, prevent updates or fixes, and even lead to a complete loss of the software product. So recovering from such a loss is often difficult, time-consuming, and costly. To mitigate this risk, it is essential to implement proper version control, maintain regular backups, and store the source code in secure, centralized repository to ensure it remains accessible and protected. Moving next, let's talk about the access control, that is weak access control. Friends, proper access control ensures that only authorized users can access sensitive areas of the application. Insufficient access control mechanism can allow unauthorized users to perform restricted actions or access sensitive information. A weak access control system might allow a regular user to access admin level features or data. Friends, weak or absent access control mechanism pose significant risks as they allow unauthorized user to gain access to sensitive information or critical system functions. So without proper access control, user may have more privilege than necessary, leading to potential data breaches, misuse of resources, or accidental system changes. Friends, weak access control can also make it difficult to track and audit user actions, reducing accountability. So to prevent these issues, it is important to implement strong access control measures such as role-based access control, multi-factor authentication, and regular reviews of user permission to ensure only authorized personnel have access to the critical areas of the system. Moving next. Friends, applications are powerful tools, but they are not without risks. So from security loopholes to the performance issue, understanding these challenges is key to keeping your app secure and running smoothly. Friends, applications are exposed to the range of additional risks that can impact the security, functionality, and performance. Interoperability refers to the ability of an application to work seamlessly with other systems, applications, or platforms. When an app can't integrate well with other software, it can lead to data transfer problems, miscommunication between systems, and inefficiencies. The latest example that a healthcare app is struggling to share patient data with different hospital systems, causing delay in the treatment. So according to a study by Gartner, 40% of the organizations face integration challenges due to lack of interoperability between software systems. Poor interoperability between different software systems can lead to inefficiencies, data silos, and increased manual work to bridge the gap between the incompatible systems. An organization using different CRM and ERP systems without proper integration may experience data duplication, delays in customer service, or errors in order processing due to miscommunication between the platform. So as a measure, adopting open standard and using application programming interface can improve the interoperability of the systems. Many modern cloud-based platforms like Microsoft Power Automate or Zapier are designed to facilitate smoother integration between otherwise siloed systems. Next, we'll talk about the backdoor. Friends, a backdoor is a hidden vulnerability or secret access point that can allow unauthorized access to an application. If backdoors are not properly secured or left in code, after development, attackers can exploit them to bypass security measures. A backdoor in a financial application might allow hackers to steal sensitive financial data without triggering alarms. A Verizon Data Breach Investigation Report 2023 found that 12% of the breaches stem from backdoor intentionally or accidentally introduced in application code, allowing attackers to exploit vulnerability. Friends, a backdoor is a hidden vulnerability or mechanism in the code that allow unauthorized access, often bypassing standard security controls. These backdoors can be introduced unintentionally by developers or maliciously as a deliberate means of gaining unauthorized access. In 2020, it was discovered that Zoom had an undocumented backdoor that allowed unauthorized access to video calls. This vulnerability posed a serious threat to the user privacy. Moving next, we'll talk about the poor coding practices. The quality of code directly impacts the security and performance of an application. Inefficient or insecure coding practices can introduce vulnerabilities such as SQL injection, buffer overflow, and other common exploits, making the app unstable or slow. Friends, poor coding practices can lead to a range of problems, including security vulnerabilities, inefficient performance, and maintainability issues. These practices include writing unclear, unoptimized, or disorganized code, failing to follow established coding standards, neglecting input validation, and ignoring error handling. According to the Software Engineering Institute, SCI, 23% of software vulnerabilities are directly linked to the poor coding practices. Poor coding practices such as hard coding credentials, inefficient error handling, and neglecting secure coding guidelines can introduce vulnerabilities, making the software less maintainable, scalable, and secure. In 2017, the Equifax data breach exposed the personal information of 147 million people due to an unpatched vulnerability in Apache struts, which resulted from poor software patch management. Moving next we'll talk about the data governance. Friends, data governance refers to the management and control of the data throughout its life cycle, ensuring data accuracy, privacy, and security. Weak data governance can result in mishandling sensitive information, unauthorized access, and non-compliance with the data protection laws like GDPR or HIPAA. A cloud storage app that does not enforce strong encryption or access control, exposing sensitive business documents to unauthorized parties. Friends, a report by Deloitte found that 62% of the companies suffer from a lack of clear data governance policies, leading to compliance failure, data silos, and poor data quality. A lack of governance over data storage and management can lead to inconsistent data practices, data loss, or non-compliance with the regulations such as GDPR and HIPAA. It can also make it difficult to ensure data accuracy and reliability, leading to operational inefficiency and security risks. In 2020, a Marriott International data breach exposed over 5 million guest records, partly due to the poor data governance and storage policies that left sensitive data improperly managed and accessible. Moving next. Friends, do you know that most application risks come from coding flaws? Fortunately, there are proven ways to minimize these vulnerabilities and keep your apps secure. Friends, application risks refer to the vulnerabilities and weaknesses within software that can lead to security breaches, performance issue, or system failure. Many of these risks often originate from coding errors, such as poor input validation, insecure data handling, or lack of proper error handling. These coding mistakes can create loopholes for attackers or cause application to behave unpredictably. However, by using proper design principles, following best coding practices, and conducting rigorous testing, these risks can be significantly minimized, resulting in more secure, stable, and reliable application. Application risks often arise from coding flaws that leave the app vulnerable to attack, data breaches, or performance issues. Poor coding practices can lead to security vulnerabilities like SQL injection, cross-site scripting, and buffer overflow, all of which expose the app to the cyber threat. So what will be the countermeasures for this? Friends, a strong design phase is critical to ensure your application is secure from the start. Before writing any code, define the security requirements and consider potential vulnerabilities during the design phase. Incorporate encryption, authentication, and secure data handling protocol into the design to mitigate risk from the outset. Friends, mitigating application risk starts with proper design, secure coding practices, and living through testing. So leveraging resources like OWASP help developers stay on top of the web application's vulnerabilities. Friends, here we come to the end of part 2 of Domain 4. For more tips on how to secure your application and reduce risks, don't forget to like, share, and hit the bell for more expert insight on application development. Thank you and stay tuned.